Right, here's the next lesson. We start off with bidmas. And bidmas means brackets, indices, which are little squares or the square roots, indices, and the other ones are divide, multiply, add, and subtract. And this generally gives you the idea that you do things in a particular order in order to get the right answer. So if we do 2 times 3, there's 3, plus 4, and 2 times 3 plus 4. So if we do the 2 times 3, that's 6, add 4, we get 10. If we do the 3 add 4 first, that's 7, times 2 equals 14. So one is right and one is wrong. Now if we look at bidmas, this is the order we do things. The M, the multiply, comes before the add. So we have to do the multiply before the add, which this one did, and this one is wrong because we did things in the wrong order. And a couple of examples of bidmas. You'll come across it all the time in regular numbers and in algebra as well. So if we've got 4 squared plus 6 and 2. Now when we have a number next to a bracket, it means multiply. There's an invisible, let's try and get that right. Come on, come on, come on. There's an invisible multiply sign in there that we never put. Yeah. So 4 squared, well, we've got to do the brackets first, haven't we? But in order to do the brackets, we have to do everything inside the brackets. So 4 squared is 16, because squared is 4 times 4 plus 6, and we're still in the brackets, times 2, and that is 22 times 2, which is 44. So the bidmas gives you the general idea of what to do and when, but you have to use a bit of common sense that we've got to do the brackets first, and in order to get rid of the brackets we have to do everything inside the brackets. So let's have a look at another one. So 2 3 squared plus 10 and divide by 10. So let's have a look at what we do with the bidmas. So brackets first. So let's get everything done inside the brackets. 3 squared is 9. 9 plus 10 is 19. And 2 times 19 is 38. So we got 38 divided by 10, which is 3.8. So you do everything in the right order. Right, so that's bidmas. Then we went on to checking. Is what we call a reverse calculation. Now, what's this? So imagine you have a £10 note and you go into a shop and you buy something for £6. Yeah, you'd expect to do 10 take away 6 equals £4, and there is your change. Now obviously the calculations you get are going to be much more complicated than this, but this will be almost your final line. You've done something or other and you've come up with an answer, and sometimes you get an extra point for a check. Now a check on what you've done to get to £4. So if you've got £4 change and you know that you bought something to the value of £6, if you add those two numbers together they should make 10. So the check is reverse, going the other way. So we're going to go 4, so we got the 4, and then we're going to add the 6, and that should equal £10. So that is what a reverse calculation is. You don't have to go all the way back through the calculation. So just the end bit will do. Now, if you make a mistake and you say I've only got £3 change, and then you do, say we do this, we have £10 and we buy something for £6, and you make a mistake and say that the answer is 3, and you do the reverse calculation for the check, so you go 3 plus 6 equals not, so now you've realized, because you've checked, that the original number and your reverse calculation is different, so you know you've done something wrong. Yeah, so you look back through your work and think, that was wrong, that should have been 4, so now it's 4 plus 6 equals 10. So it's a way of checking. Yeah, so if you make a mistake in your original calculation, the check should highlight what you've done wrong. Yeah, and that's an extra little point that you get for that. Right, so reverse calculation, after we did that, we did just go through some squares. Squares and square root. Square root. Now, this is how we write a square. We put a little 2 at the top, which you see one just now. And this means 2 times 2, which equals 4. Now, if we do the square root, that's the square and that's the square root. If we do the square root of 4, then it is a number times itself, which equals 4, which is 2. So 3 squared is 3 times 3, which is 9. And the square root of 9 is 3. 4 squared, 5 squared. I don't know how many we need to do with this, but these are things to remember. It's just in the times table, yes? So 8, 9, and we just go to 10. Yeah. So 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100. So the square root of 16 is equal to 4, the square root of 25 is equal to 5, square root of 36 is 6, 49 is 7, 64 is 8, 81 is 9, and 9, and 100 equals 10. Yep. So that's squares and square roots. We just touch on some cube roots and cubes. So if we've got this and we have a little 3, then it's cubed. That means 2 times 2 times 2. Do it 3 times, which equals 8. So the cube root, and we put a little 3 there now, of 8 equals 2. And we don't have to remember too many of these. 3 cubed is 3 times 3 times 3, which is 27. So the cube root of 27 equals 3. 4 cubed is 4, 4, 16, 64. Cube root of 64 is 4. And 5 cubed is 125. And so the cube root of 125 is 5. Funny 3 there. 6 cubed. I think that's 216. Pull me up on that if this is wrong. Memory. Trying to remember them all. Don't remember what 7s are. That's as far as we need to try and remember. Okay. Next bit looked at in this lesson is using negatives when multiplying and dividing. So when we write 4 times 4 equals 16, these are all positive numbers, so we don't bother to put the plus sign. We don't write plus 4 times plus 4 equals plus 16. It's just too much bother. We don't bother. So what we've got is when we're multiplying two pluses together, we get a plus answer. So a plus times a plus equals a plus. Now, what if one of these minus 4 times 4? Well, 4 times 4 is always going to be 16, but this time the answer is a minus 16 because a minus times a plus equals a minus. And we can swap these around the other way. We can go 4 times minus 4 will also equal minus 16. Excuse me, because a plus times a minus equals a minus. And minus 4 times minus 4 equals, bizarrely, plus 16. Because a minus times a minus equals a plus. Now, easy way to remember this is when you have the same signs, plus plus, they equal a plus, or minus minus, it equals a plus. So when they're the same, it equals a plus, but when they're different, it will equal a minus. And this is the same when we're dividing. So let's do 10 divided by 2 equals 5. See, we've got a plus divided by a plus equals a plus. Minus 10 divided by 2 equals minus 5. So a minus divided by a plus equals a minus. 10 minus 2 equals minus 5. A plus divided by a minus equals a minus. And the last one is minus 10 divided by minus 2, which will equal a plus 5. So minus divided by minus equals a plus. And again, same signs equals a plus. Different signs will equal a minus. The next part of this lesson was or is decimals, and we're going to add, subtract, multiply and divide using decimals. Right, now add and subtract and multiply are pretty much the same as regular numbers. So let's have a look at add. 3.8 plus 2.6. Now here, keep things in columns. Keep the dots above each other. Yeah, so the answer is the dot's going to be there, the decimal point. So 8 and 6 are 14. So we've got 4 carry 1. 3 and 2 are 5 plus 1 is 6. So your answer is 6.4. Exactly the same. Yeah. If we've got 3.85 minus add 2.1, again set things out so that you've got the dots above each other in a column. And so you could put a 0 in there if you wanted to make it easy, but 5 and nothing make 5, 8 and 1 make 9, and 2 and 3 make 5. Yeah. Now when we're subtracting, so 4.6 minus 2.3, exactly the same. Keep them in a line. 6 minus 3 is 3. 4 minus 2 is 2. And we do this 3.85 minus the 2.1 again. Use the same numbers but subtract. So nothing from 5 is 5. 1 from 8 is 7. And 2 from 3 is 1. So we get 1.75. Now, there is a case where when you're subtracting, the number on the top is smaller than the number on the bottom. So we'll do this. So we'll do 5.3 minus 2.6. And we start from the right again. Keep them in columns. 3 minus 6 we can't do. So this is a case where we have to borrow from the left. Exactly the same as when we're doing regular subtraction. So borrow from there is 4 and 1. So we've got 13 minus 6, which is 7, and 4 minus 2, which is 2. Right, so 5.03 minus 0.44. So 4 from 3 can't go. So we're going to borrow. There's nothing to borrow there. So we have to go along another one. And we'll borrow 1 off the 5. Call that 4. And then this becomes 10. Then we borrow 1 off the 10 and stick it next to the 3. So this becomes 13. So now we've got 13 take away 4, which is 9. 9 take away 4, which is 5. There's the decimal point. 4 take away nothing is 4. Yeah. So watch out for that when you're borrowing numbers. So add and subtract. So multiply 3.6. Let's have a look. Let's do 2.1. Okay, so we're going to multiply now. So don't worry about the decimal point. Just think of it as 36 times 21. So you start from the bottom right. So 1 times 6 is 6. 1 times 3 is 3. And then go over to the 2. So you need what's called a place marker so that your first answer comes directly below the 2. So 2 times 6 is 12. That's 2 carry 1. 2 times 3 is 6 plus 1 is 7. Now you need to add these two together and try and work out where the decimal point goes. You can do it two ways. You can just take the whole numbers. 3 times 2 equals 6. And that will give you a rough idea of the magnitude of what you'll multiply. So it's going to be 6, but it's going to be a bit more than 6. So it might be 7, but it's not going to be 60 or 70 or something. And you see there we've got 7.56. That's where the decimal point goes. So it's 6 and a bit. Yeah. Now the other way to find out where the decimal point goes is this way, which is you count the number of decimals after the decimal point in what I'll call the question. There's the question. And in the answer, we have the same number. Don't add them. It's just how many there are. There's 1, 2. So there's 2. So we need 2 after the decimal point. So that's another way of finding out where to put the decimal point. Now, with multiplication, you don't have to get things in line. You can do 3.64 times 1.5. Yeah, so it doesn't matter about where the decimal points go. So you just go 5 times 4 is 20. 5 times 6 is 30, plus the 2 is 32, and 5 times 3 is 15, plus the 3 is 18. And then place marker, 1 times 4 is 4, 1 times 6 is 6, and 1 times 3 is 3. Add them together. 2, 4 is 6, that's 14, and 4, 5. So we've got 5460. Now, where's the decimal point go? So we do it this way. 1, 2, 3. So now we include this 0. 1, 2, 3. So the answer there is going to be 5.460. Yeah, it's 3 times 1 and a bit more. Yeah, 5. So now that we did count the 0 when we were seeing how many places it was before we put the decimal point in. But when you write your final answer, you can just put 546 and drop the 0. We don't need a 0 at the end, but we do need it when we're counting. So that's multiplying with decimals. Then we divided. we divided with decimals. So 20 divided by 0.5, and we've got to get rid of the decimal because it's, with no calculator, it's going to be really difficult to divide by a decimal. So the way to get rid of this decimal is if I double it, I multiply by 2 and I get 1. And what I do to one side, I do to the other. So that would be 40 divided by 1, which equals 40. So 20 divided by 0.4. Now, if I double it, I'll end up with 0.8, so I'm not getting anywhere. But the way to get rid of the first place decimal, guaranteed, is just multiply by 10. And so I will get 4. And now I need to multiply this by 10, which is 200. And now I'm going to do 200 divided by 4. Much easier than trying to divide by 0.4. 4's into 2 don't go. 4's into 20 go 5. And there's a 0. So your answer is 50. Just do one more of those, yeah. 66 divided by 0.3. Okay, that should go in okay. So let's get rid of that decimal. Times it by 10, which gives me 3. Times that by 10, which gives me 660. So now I've got 660. Divide by 3. 3's into 6 go 2. 3's into 6 go 2. And 0 at the end. So my answer is 220. Next little topic that we looked at was converting decimals to fractions. Right, now a decimal, 0.4, right? 5, 6, whatever. The 4 is in the tenths column. The 5 is in the 100ths column, and the 6 is in the 1000ths column. So if we are going to convert that into a fraction, we see that the column is the tenths, and I've got 4 of them. Therefore, I've got 4 tenths. Yeah, 0.7 will be 7 tenths. 0.9 will be 9 tenths, and so on and so forth. If it's in the next column, 0.05, this is in the 100ths column, therefore this will be 5 100ths. 0.03 will be 3 100ths. And the same for the thousandths column. I'll just do one of these. 0.006 will be 6, because it's in the thousandths column. 6 over 1,000. Now, what happens if we've got two numbers in there instead of just 0, 0? So 0.24. Now this is in the tenths column, so we've got 2 tenths. This is in the hundredths column, we've got 4 hundredths. So we'd look at the last number. Look at the last number only. The last number determines the denominator of the fraction, the number underneath, which is over 100. And we take all the numbers now and go, we've got 24 100ths. Yeah, 0.047. The last number is in the thousandths column, so this will be 47 over 1,000. All right, and that was that lesson. Okay,